All right, well, good morning. It's a privilege for me to be here. Thank you to the Gerrie team for inviting me here today. As noted, my name is John Dyke. I'm Director of Software Business Development. I'm actually from Ontario. I spent most of my life and my career here in southwestern Ontario. I've been in Cleveland now for just over 10 years, but I'm proud to say I still have my Canadian passport, for the record. So what I'd like to do is be a little bit provocative this morning, just to kind of provoke you a little bit into thinking in ways that you're probably not comfortable and maybe not used to thinking. We talk about cloud in manufacturing, and the sort of the first reaction tends to be one of a little bit dismissive. That's probably for someone else. Maybe that's for other parts of our organization that are doing non-critical things like payroll and CRM, customer relationship management, and certainly for me on the plant floor, it's not that relevant. But what I'd like to do is talk to you in ways that hopefully convey to you that this is a really, really important part of your strategy over the next 5 years, and that you're doing things today that can prepare you for maximizing and creating value around some of the things that these new capabilities will bring to the table. And I'll hopefully be able to clarify what I mean by saying that. Let me ask a couple of questions here just to make sure I understand my audience. We talk about OT and IT like it's sort of a black and white thing, and it's often not. But just by a show of hands, how many folks here are from more of an IT perspective than an OT? It's a lonely place, right? two or three. OT, the rest of you, I presume? Yeah. What about those of you that are here from a machine builder OEM perspective? A good portion. I'm sure the rest are a combination of systems integrators and end user manufacturer producers. That's important to me just to make sure that I talk about the different sort of sources of value for each of those different roles or each of those sets of stakeholders, because they are in many cases unique. One of the things that everybody sort of does when they start talking about this space is spout off big numbers, right? We talk about the value creation of the Internet of Things being 3.8 trillion. I think that's a number that I can't even wrap my head around. But the reality is, this is what the CEOs of manufacturing corporations all over the world are looking at. In Europe, it's the Industry 4.0. In China, it's China 2025. Here in the US or North America, it's about smart manufacturing. Rockwell's sort of big story around this is the connected enterprise, which I'm guessing you've heard about. But the reality is, these are really, really big numbers. What can we do to capitalize on that? And as Gerrie said in his introduction, your organizations, in some way, shape, or form, are looking at this and saying, what the heck? What does that mean to me? There's got to be something in this for me. And working as much with IT and as I do with OT organizations, there's a sense of hope and a sense of rejuvenation, even from an IT perspective, saying, what can we do with these innovative new technologies to create value for our organization? So I've seen a resurgence of IT getting engaged in the OT world to help figure out how can we take the important data. We talk about data as the new currency, and yet in our world, in the OT world, much of the data sort of stays uncollected and certainly stays unanalyzed. So what can we, from an IT perspective, do to enable the OT part of the organization to capitalize on this? And so that's a little bit about where the future-looking sort of innovation and the new technologies that I'll be talking about come together to help us figure out how can we actually capitalize on this massive opportunity, and what can we do today to start, as Gerrie mentioned. So I think there's sort of been a couple of decades now, and as you can tell, I'm no spring chicken in this manufacturing world. I've been in this sort of manufacturing software space for 2 decades now, focused solely on how can we create value from our manufacturing assets here. And the reality is, we've been talking for all 20 of those years about some variation of shop floor to top floor, sensor to boardroom, plant to enterprise, some sort of, what can we do to connect the automation world to the enterprise to do some more important things. But the reality is, for 95% of manufacturing, we're little further ahead today than we were 20 years ago. There really isn't a significant step change in productivity or really technology advancements that have taken us from where we were 20 years ago to that place of nirvana where we have a fully connected, fully automated environment between the automation world, the actual manufacturing operations, and the business side. So I've tried to sort of create a sense of maturity to try to, working with, I'm on the board of directors for an organization called MESA, stands for Manufacturing Enterprise Solutions Association, getting a broad perspective on where manufacturers sit across these different spectrums from a maturity perspective. There's really three traditional dimensions: people, process, and technology. From a technology perspective, sort of ranking yourself on a maturity model here, on a maturity spectrum. On one end is your equipment disconnected, on the other end is your equipment connected. And broadly across the manufacturing organization, we find that roughly, statistically, 14% of your equipment is on a network that you can ping from your corporate headquarters, let's say, which means that 86% of your machines are not connected. So the idea of collecting data and creating value from that data, using that data as currency, is kind of a non-starter for a lot of manufacturers, or at least large portions of the equipment that are in most manufacturing organizations. So from a maturity perspective, kind of the middle of the bell curve is 14% of your assets are connected. In terms of process, how effectively are your business processes, your workflows in your organization integrated with operations? On one end of the spectrum, you've got disparate systems, manual reporting, a lot of sort of end of the shift heroics by people from all parts of the organization, gathering data and trying to bring it up into some sort of a reporting format to help the end of shift transition from production or maintenance to the next shift, and figure out how to improve, or what to focus on. What are the challenges we saw last shift, and what can we focus on now? So again, most of the manufacturing, the middle of the bell curve, is significantly to the left side of that spectrum. And last but not least, from a culture perspective, it's always about people. We can do all we want about technology and the technology world, but in terms of a culture, how data-driven are we? Are we making decisions based on manual data entry, based on information people have gathered and have had the chance to influence? Are we purely data-driven? Are we able to look at the facts, look at the data, and make decisions either in real time or from a broader planning perspective, even for the supply chain, in a more automated way? So the reality is, as I said, for most, the middle of the bell curve for manufacturing, from a maturity perspective, we're pretty far on the left-hand side of that, as opposed to, I think, where we might have envisioned we would be 20 years ago. And so it's important from our perspective to understand those historic complexities if we're going to figure out in this next iteration of technology, in this next wave of technology, what can we do to capitalize and improve. We have to sort of understand our constraints and our challenges if we're going to truly capitalize on things moving forward. So that's the current state of the industry. The value creation and the opportunity in front of us, if we can sort of create and build on a strategy to leverage these new capabilities over the next few years, this is the opportunity in front of us. And this is truly a journey. This is not something that you strive to and build a plan for and achieve. This is a journey, absolutely a journey, to be clear. So just a simple pictorial here to say that what you all do, what we do from an automation perspective, what we do on the plant floor, is vital to every part of our organization. And yet, most of the big corporate functions around us, around the shop floor, who depend on what we do for a living and for whom we are the source of all important things, they're still working on a data set, for the most part, that's either assumed, that's some sense of what we plan to produce and build, but rarely what we actually did build. And so the plant floor in most organizations is still truly a black hole. And what that means is your R&D folks, your design folks, they don't have a clear perspective of how a specific product or process is performed. as they're looking for the next capital investment to move forward. Your supply chain folks, they don't have a real sense of what the real-time constraints are for my supply chain right now and what to do about that from a planning perspective. Your VP of operations rarely has the data that he or she needs to create and invest in, and make capital investments in their organization. And in fact, most plant managers are living on what I call a baler twine and duct tape mentality, where I get the fire of the day and I'm focused on that and I'm just doing what I can to stay alive, make sure I'm safe, make sure I got quality product coming out the door. Looking forward to tomorrow is really not part of my purview, because I really don't have time for that. So that's sort of the reality that most of us find ourselves in today. So with that, what can we do to think about the future? Where will this industrial IoT thing fit into my world, and what can I do today to truly create value for my organization? Well, with the experience that we've gained in the last 5 years at Rockwell Automation, I'm sure you've all had some sense of exposure to what the sort of automation landscape is doing in this area with GE and Predix and Siemens and MindSphere and Microsoft, Google, Amazon. Everybody's investing in this space, IBM. There's a tremendous sense of hope and a tremendous sense of optimism that these new technologies will transform what we do in manufacturing. Well, with the experience that we've gained over the last 5 years, I'd like to talk to you about these two specific ways that these new capabilities can create value, and that you and we all need to be working towards and preparing for. One is around the infrastructure and the value that in and of itself will bring. And the other part is the technological innovation that's created through that new set of infrastructure and those new analytics and other capabilities. So let me ask you a question here. In 2010, it cost roughly $80,000 to create 1 petabyte of storage inside your firewall. So for your IT organization back in 2010, to create a 1 petabyte storage system for your organization, it cost them $80,000. What do you think that petabyte will cost in 2 years, in the year 2020, if you do that in the cloud? 1 petabyte of storage in the cloud in 2020. Any guesses?
$1,000.
Pardon me?
1,000.
1,000. Do I have 2? Do I have 500? Any others? $100. Any others? That's pretty extreme. Any others? 500? $4 per month per petabyte, right? And in many cases, your kids know this. You get unlimited storage on Google or Amazon for your photos. That's data storage. And this is a little bit of hyperbole, right? There are cheap ways to store data in the cloud, and there's more expensive ways to store data in the cloud. If you're looking at blob storage for things like images and massive data sets, it's cheap. If you're storing relational data in SQL Azure, it's more expensive. But the point is, this is a juggernaut, right? When you guys are installing systems on the shop floor, when you're looking at historians or SQL databases, Oracle databases, you're very, very aware of what each tag costs. You've got the server, you've got the database technology, whether it's OSI's, Historian, or GE's, or AspenTech's. You've got the expertise to maintain and sustain that system, and then the OT expertise to configure those tags and bring all of that into the right environment at the right frequency, at the right pace, and those databases grow over time. So all of that has to be maintained, sustained, and maintained. So every single tag, in most organizations, I would say 9 out of 10 organizations, every single tag that you configure today is purpose designed for some report or some problem that you need to solve. What if in this new world where data is almost free, storing data is almost free, what if you could store every bit of data from every PLC and every HMI platform you've got out there forever, right? That would dramatically change your world. I can say with no exceptions, we've been working now for about 2 years on the predictive analytics side, mostly working out how to scale these capabilities, how to build this competency within our own organization so we can productize it and scale it. With no exceptions, and probably several dozen customer engagements, with no exceptions, have our customers actually been collecting the data we need to do predictive analytics. So the idea of predictive analytics is real, and I'll talk about that. It's obviously a hugely valuable thing. This is not just saying that that thing historically failed every 2 months or every 18 months, and so it's going to fail again, so we better do some predictive maintenance on it. That's not what I'm talking about. I'm talking about true predictive maintenance or predictive analytics. We just don't have, we collectively are not collecting enough data because of that constraint, right? So there is a juggernaut here that says, just on the data storage side alone, plus the compute and all of the other cost areas, you will see massive opportunities. Your organizations will find ways to address your concerns, whether it's policy concerns, whether it's security concerns. And I'm not saying everything will go to the cloud, but again, I'm here to be provocative today, to help sort of poke you a little bit, to move you in this direction. To think about this in a more serious way instead of just sort of dismissing it. This is something that your organization is paying attention to. I'll give you a simple example of life at Rockwell, and this is a little bit of dirty laundry. Before the advent, or before our adoption of cloud internally, guess how long it took? And I won't ask you for any numbers in your organization, but if I wanted a server, stand up a server for whatever purpose, testing or development or even just doing demos, if I wanted to stand up a server, acquire and provision a server for my organization, it took me minimum, the SLA, the service level agreement that IT has with me is 90 days. It went from the day that I go online and say, I want a server with these characteristics, for these purposes, justified, paid for by, it's all legit. 90 days for IT to deliver a server for me. And I'm guessing, maybe IT is much better where you are, but I'm guessing it's probably not similar from your perspective. Guess what it is today? 24 hours. And if I need it in an hour, I can get it in an hour in the cloud, right? So it's literally a very dramatic difference in the ability, from a pure infrastructure perspective, to deliver these capabilities to your organization. Another important data point, this is from a global manufacturer, but the numbers are generally consistent across the board. This is a US Fortune 50 manufacturing company. They did some research a couple years ago to determine what's the cost of ownership for a server on the plant floor. From the time I acquire it and plug it in and power it and maintain it, just not the applications, just the physical server. The total cost of ownership amortized over 4 years is $80,000 for one server, right? So most organizations haven't done that kind of homework, but what that did for them was they said, okay, we're going to work with Rockwell and Microsoft to make sure that we've got the right security constraints, or we've addressed our security concerns, but our new policy is cloud first, even on the plant floor. Not to say, like I said before, that everything goes into cloud, but the bottom line is, if you don't justify why it has to stay on-premise, it's automatically going to be created in the cloud. So that's what more and more of our manufacturers are doing, and this is the beginning of why. It's the pure infrastructure cost of ownership around the reality that data storage is just about free. On the other side of that, when we talk about the investment in AI, when we talk about the investment in communications and silicon, today, or historically, putting a PC on a machine, if you're a machine builder, OEM, putting a PC on a machine is costly, it's complicated, you have to convince your customers there's a good reason for that PC, and it's expensive. The idea that you can put something like a Raspberry Pi, which is essentially an appliance, a headless appliance, that has enough horsepower and has a basic service on it to move data to the cloud, that radically changes the business model for an OEM who can now put a low-cost appliance on a machine and move data to the cloud securely and provide new services to their customers. So back to the idea that from a compute, from a storage, from a memory, from a silicon perspective, every vendor in this space, IBM, all the chip manufacturers, ARM and Intel, they're all investing significantly. The cost of all of these components is going down to the point where putting an asset, connecting an asset, let's say we're in the middle of Texas and we've got a pipeline and I've got a compressors and pumps scattered all over the world. ExxonMobil, for example, has 40,000 pumps and compressors all over the world, most of which today are not connected. And it's because of the fact that today it's way too expensive. At least historically it has been. We're now working in a scenario where it's feasible and cost effective to connect these assets in a way that is actually sustainable and creates a return on investment. So the total cost of ownership of the infrastructure, of connecting things, of moving and storing data is going to transform, in and of itself, is beginning to transform our world of manufacturing. The other really important piece is, historically, you've got sort of a very traditional, if you're familiar with Purdue model, level 0, level 1, level 2, level 3, level 4, you've got a very traditional way of moving data through the organization. It starts with my sensors, moves up to a PLC, maybe up to my HMI SCADA, historian. I've got an MES platform that goes through there, and then if I have connection to the enterprise, it goes to my ERP system. So information starts here and it sort of gets aggregated and maybe loses some granularity, and then it gets aggregated up in my historian, and then it gets aggregated up in my MES system, and finally, some version of that, a week late, arrives in my business system for me to do a better job planning or reacting in my supply chain. So the reality in this new world is that every layer has an opportunity to talk directly to my IoT platform, right? It's now feasible for a $10 sensor to have an IP address and to be connected to the internet securely through your firewall. So the idea is that the cost of ownership of these capabilities, as I mentioned, is going to allow me to take, I'm not suggesting you don't connect through your PLC, but for a specific set of sensors or devices that are out there, smart devices, you may want to send an alert directly, in addition to my PLC for whatever control program it's running. You may want to send an alert directly to Maximo or SAP PM to send a maintenance guy out there immediately. Open a work order and send a maintenance guy out there immediately, right? Or if you've got some sort of support organization that's outside your firewall, those events don't have to travel through the Purdue model, through that hierarchy of systems before they're relegated to some sort of late response to that real-time event. So that's a huge part of what we can do now in terms of creating value, thinking differently about the cost of connecting assets and about how that data can be effectively used inside the organization for various purposes. And again, when I talk about the customer use cases, I can drill into that a little more. One of the huge investments in this space that Jonathan Wise will talk about at length this afternoon, which is why I'm not drilling into it, is the idea of analytics. And that deserves the time and the bandwidth for that discussion later on. But suffice it to say that with the investment that all the big players are making in cognitive analytics and predictive analytics, there is already a huge impact and a significant opportunity for us to bring those capabilities to you in a way that allows us to do analytics where they're optimized to be, whether it's right at the machine level, at the edge, or in the cloud for significant predictive analytics purposes. So Jonathan will talk to you more about that. I'll take just a couple of minutes to talk about Rockwell Automation's industrial IoT platform, our cloud platform. It's called the Frac Trucks Cloud, based on Microsoft Azure. We can talk at length later if you have any questions about why it's Azure and not Amazon or Google. But for a bunch of important reasons, we've selected to work with Microsoft as our cloud provider. What we've done is created a highly scalable way of connecting devices and systems to the cloud. We have this new capability called the Cloud Gateway. It scales down to a small sort of Raspberry Pi-like gateway appliance, all the way up to a server-scaled, enterprise-ready blade server environment. So you can scale that according to the amount of data that you want to move up to the cloud, whether it's a single $50,000 machine or whether it's an entire plant floor. So you've got the Cloud Gateway piece to securely move data to our cloud platform. You've got the platform itself, and then you've got sort of what you do with it from a business process standpoint, a workflow standpoint, a visualization and analytics standpoint. From our perspective, drilling briefly into each of those layers, we have a sort of a user experience for OT purposes. We sort of talked about that in high level terms around the things that an operator or somebody in a maintenance or production role might want to use that type of environment for. If you're in a Microsoft environment, you're probably familiar with Power BI. It's probably the world's leading analytics and BI platform. Great for mashing together large data sets, bringing the OT information into the rest of your organization, any data lakes, any sort of large scale data sets that your organization is using from other businesses, bringing that data into a Power BI environment. And then for more of an IT purpose, if all you want is the data for a data lake or for some other analytics purposes or long-term storage, we can take that data and just move it into, from an extensibility perspective, move that into whatever environment your organization is focused on or standardized on. So from our perspective, what we can do is help create access to that data. Once those assets are connected, once that asset is providing data that can be stored in our cloud platform, we're in a great position to help you share that data with the different functions in your organizations, your quality, your designers, your support folks inside the organization. But also, we have a multi-tenant way of sharing that data, allowing you to control what suppliers, what machine builders, what remote support folks, remote monitoring organizations you provide access to so that they can help you with your organization. In other words, if you've got an important machine builder as the manufacturer, if you've got an important machine builder that can help you drive productivity over, say, a 6-month window, help you improve the way that machine is performing because it's a bottleneck. It's the constraint in your organization. You can move the data from that machine or those machines into our platform and through a sanctioned, secure way provide a subset of access to that machine builder so they can see in real time what's happening and they can make suggestions. They can predict when that machine's going to fail. They, as the folks that designed and built that machine, can help you optimize the performance of that machine. That's what we're seeing more and more about. What this enables is a level of collaboration between the OEM machine builders and the end users that are buying those machines, which today, for the most part, those machines are built, they land in the plant, and from the machine builder's perspective, they go dark, right? The folks that designed and built that thing never have access to that machine or that data and have very little incentive to improve the design of that machine because they don't have access to the way that machine is performing inside different types of environments. So again, and in many cases, your supply chain, your customers. So one of the sort of bigger picture things that a lot of corporations are working on is how can I take information from Twitter, from Facebook, customer sentiment that says, I'm pissed off because my diaper tags weren't folded properly and they're not working properly for my kids, right, for my baby. So we're looking at tying customer sentiment and warranty issues back into what's happening in real time in the manufacturing process so that we can recall exactly what was produced based on information that we can gather in this environment. So the notion of integrating whole new data sets with real-time operations data is a pretty exciting way for us to think about going forward. So how much time do I have, Gerrie?
Plenty of time.
Plenty of time, okay. So let me walk through 6 or 7 customer use cases here. Shell is building liquid natural gas retail stations all over the world. Literally all over the world. They came to us a couple years ago and said, hey, here's your RFP, Rockwell, knock yourselves out. It's a traditional control system at each station, 6 or 7 variable frequency drives, several hundred sensors, and an HMI SCADA system so we can just kind of monitor this thing remotely. We said, well, listen, Shell, given the scale of what you're doing, why don't you let us work with you to architect a cloud-based solution instead of a traditional SCADA system that you're looking at here, and here's why. We created a strategy and gave them a justification for it. And it wasn't that HMI SCADA wasn't the right answer, because they ended up still putting a panel view locally at each site. But what this allowed us to do was begin looking, as they're scaling these assets up, and I'm thinking now about water, wastewater systems, municipalities, the different types of assets that we might consider as remote assets for this scenario. What we can do is begin figuring out how these retail stations compare to one another. If I have data in real time from consumer demand at this station, and it's in this part of the country, and I've got the same data from that one over there, I can begin comparing how they're failing, how they're being used, what consumer demand looks like. And then even more importantly, because there's 5 key vendors that supply goods to each of these LNG stations, we can begin not just responding when certain thresholds are met, we can actually begin predicting what consumer demand looks like, and we can order in advance, make sure that supply chain has enough notice in advance of that consumption, of that consumer demand, to replenish whatever it is those suppliers are bringing. So we begin driving true analytics, predictive analytics, into this process to ensure that we've got the right level of service at each LNG station, which would have been very, very costly in a more traditional setting. So that's an exciting story. We've now, the numbers exceeded 29 pretty dramatically. This is the other part of the cloud that's important for any manufacturer that's got global operations. There's countries all over the world that are creating new regulatory requirements for how data gets stored and accessed. If you do this in the cloud in the US, you can't connect a German or a Chinese or a South American or an African LNG station to the same instance. You've got to be able to comply with all the regulatory compliances. It's called data sovereignty laws in each of these regions of the world. So from our perspective, working with Microsoft, it's become a very simple thing for us to do this in China, as it is in Africa, as it is in Australia, as it is in South America, or Eastern or Western Europe. So the notion of doing this globally becomes a very, very simple thing to sustain going forward. Anybody heard of Metso? A couple folks. They're a large European OEM for the most part. They build massive rock crushers, at least in this business, probably the biggest part of their business. And they're in some of the most difficult spots in the world. We began working with them a little over a year ago, and they gave us the most difficult mining operation in their experience, which happened to be a country in northwestern Africa in the middle of nowhere. They said, all right, if you guys say you can do this, we'll give you the most difficult challenge in our organization. Can you connect this massive rock crusher, which is going to surface about 10,000 data tags per second, vibration, energy, fault data, cycle time data, all of the information this thing produces, at least within reason, bring it up to our cloud platform and help us figure out where our constraints are, how we can design a better machine for these remote environments. So we were able to do that very, very quickly, and last summer they announced globally that Rockwell, together with Microsoft, they're a global IoT platform for their entire organization. It's a great story because not only in that very first instance were we able to solve their immediate problem, but what we did was help point out a challenge that allowed them to improve the design of that machine in a way that will immediately generate millions of dollars of return on investment that they didn't even anticipate. And that's the hallmark of these cloud-based systems. With no exception, and you'll see that in the next few stories as well, the value that we achieved, the return on investment, was often in areas completely separate from what we anticipated them to be in the first place. So yeah, we did what they expected us to, but there was this massive unanticipated value in ways and in areas that we didn't anticipate. And that's just a function of new technology and exciting new capabilities. First Solar, based here in Ohio. This is kind of a unique use case. They are the first customer that we have that's actually using the cloud, not just for information and reporting and analytics, but to do control. So their strategy is they're building these sites across around the world, mostly in emerging markets, low-cost emerging markets. Their challenge was, for their NES systems, it was a massive IT burden to build both primary and secondary backup MES infrastructure for their manufacturing operation. So they basically came to us and said, we'd like to build a system where the primary IT infrastructure, MES IT infrastructure resides in the plants. But if the primary goes down, I want one backup system globally for each of those each of those operations. And so I need a way of ensuring that I get data from those plants, that I can make a decision in my MES system and securely send control data back to the plants without any challenges from a latency perspective. So I will say this, 99% of the opportunities that we see now and for the foreseeable in the next year to two are going to be exclusively information and analytics, so I'm not writing back. In fact, it's a benefit to not be able to write down back to my automation system. But in this case, we created a new capability in our cloud gateway that allows us to, with low latency, control their operations. Like I said, move the data to our platform, make that workflow, business process, execution decision, and then control the plant floor in real time with sub-second. 85 to 90% of all transactions can come back to the plant in less than a second. So pretty exciting new type of use case. This is a Fortune 50 food and bev company headquartered in the US Midwest. They were looking for ways to quickly scale up performance and a production performance system. They had tremendous experience and maturity doing this on premise, but it was, from their perspective, it took too long to deploy and it was too costly to do this on premise. This, in fact, was the organization that did the research to figure out that standing up one server cost $80,000 cost of ownership over its 4-year life cycle. So this organization basically stood back and said, all right, Rockwell, can we work with you to create an off-premise, public cloud-based performance management system for all of our plants that we can scale out one per month? There's obviously some real constraints there, but we were able to very quickly take the key sort of pay points in their manufacturing organization, which were the actual packaging lines, which is where the product goes from manufacturing into the warehouse. Take the sort of key OEE and quality and performance and actually safety and morale data from their ERP systems, bring that all together in our cloud platform, and created 4 simple dashboards for each of those plants. So it's a very, very compelling way of mashing together important data sets for the corporation to look at each plant in a standardized way, and to do so at a rollout rate which was phenomenal, right? So in other words, doing one plant a month for the first year and then several plants a month after that. This is an interesting example of sort of us eating our own dog food, if I can use that phrase. Seeing what we were doing for our customers, our customer support organization looked at this and said, we can create our own remote monitoring service for our customers. And we'll start with our larger, more expensive assets, in this case, medium voltage drives, and our larger low voltage drives, and we'll equip every one of them in the factory with this cloud gateway appliance. It's part of, actually here in Cambridge, it's part of the assembly process to include this small, low-cost appliance on every medium voltage drive. And then our sales team around the world, when they sell these drives, they can just check the box and say, do you want Rockwell to provide remote monitoring services for that drive? And here's what we give to you. This is, as you might imagine, this is the Gulf of Mexico. This is Texas. This happens to be a massive pipeline that runs through the heart of Texas. These are big compressors on the pipeline. And our guarantee to you, Mr. Customer, is if that drive fails, we will call the right person within 10 minutes. We know that it failed, we know how it failed, we likely know why it failed, and we're going to call you within 10 minutes, worst case scenario, and help you bring that drive back online. So that's a great example of us taking that cloud platform and making it scale globally for any of our customers that have assets, machines, that we can provide a better support level than we might otherwise do. So we've gone from doing this from just a pure sort of device perspective, remote monitoring for these actual medium voltage, low voltage drives, to a variety of different machines and assets. We're supporting customers that have packaging equipment. We're supporting networks. We actually have, in fact, that same Fortune 50 food and bev manufacturer. We have that same support SLA, remote monitoring SLA, for all of their Cisco devices, all of their control networks, so that when they fail, we're proactively monitoring them, looking for thresholds, predictive failure thresholds, and actually providing that same SLA for control networks, pulp and paper machines, large smelting equipment. So we've gone from our very first foray into remote monitoring for devices that we build and understand to providing much more domain-rich remote monitoring capabilities using this cloud platform, and the foundation, the idea being that we can move this information securely and cost-effectively to this cloud platform and help you create a new business model or a new support level agreement for that. This is an interesting use case where this was our very first customer. Anybody, an automation fair 4 or 5 years ago, we had a massive fracking truck on the automation floor, show floor. MG Bryan built this, had for 2 decades been building these massive frac trucks. It's $1.5 million, $1.2 to $1.5 million mobile factory, if you want to think about it that way. It had a massive diesel generator, a massive pump, and a Caterpillar powertrain or drivetrain. So we put a compact Logix on every truck. We had a CAN bus interface to the drivetrain, and obviously to the generator and the pumps and the compressors and all the other instrumentation on this fracking truck. Their initial goal was simply to do one thing. When those trucks are in the field, they've got 7 or 8 different filters on them. They're low-cost filters. But those filters fail in the field, and it's obviously bad enough to have a fracking truck stop fracking. But those trucks come back with a $400,000 pump that's now failed because they didn't replace an $80 filter when it was supposed to be replaced. And so that comes back as a warranty failure. So their warranty costs were just, way out to lunch. So their goal was to build a new services and support organization to help their customers understand when to replace these filters. Pretty simple goal. So they did that. We did that with them. It was a really compelling application. But guess where they actually found the unanticipated value? So today, or historically, when that truck goes out to the fracking field, somewhere on a schedule, a guy or a gal on a pickup truck goes from fracking field to fracking field, and they stick a USB plug, a USB stick, into a black box on the fracking truck, and it downloads the file automatically. And then every 60 days, they show back up at the factory at headquarters. They download all these files from their USB stick, and then they can invoice their customers. What we sort of stumbled upon for them was that, man, we know exactly what's happening with this fracking process. We know the minute that it's done. We know the shape of the well, the shape of the fracking environment. We know everything about this thing. So within a minute of that well being fracked, we can send an invoice, an automated invoice to our customers. So another simple example of how the anticipated value was X, and we delivered that, but the unanticipated value of invoicing our customers immediately versus 60 days from now was probably 10 times the ROI of what they anticipated. Last but not least, we've taken this same cloud platform and created a FactoryTalk Cloud, FactoryTalk for Machines, Analytics for Machines capability, where we've taken kind of the middle of the bell curve for most traditional machines. And we basically said, you wire these 80, 90 tags into this predefined data model. We're going to give you this set of dashboards, this set of KPIs, OEE, and mean time between failure, mean time to repair, process variable trends, alarms and faults. We're going to give you this basic set of stuff that's prescribed in this way. It's kind of in a box. But you do this, we'll give you this, and the cost per machine per month is ridiculously low. It's a way for us to help our OEMs create new business models, to instrument their machines with this capability so that they can actually work with their customers to convince them that they can do a better job supporting their machines and creating a better asset utilization, a more efficient machine than what they have today.